Hi class, we are now on 11.2a, Electrolyte Solutions. So in the previous chapters, we introduced solutions of ionic compounds in water. Recall that when ionic compounds dissolve in water, they dissociate. That is, they separate into positive and negative ions. Because of these compounds increase the ability of water to conduct electricity, they are commonly called electrolyte solutions. Covalent compounds generally do not ionize in water. An exception to this occurs with acids, compounds that contain weak polar covalent bonds to hydrogen. In water, these bonds break to produce H+, or what would be called a hydrogen ion or a proton, cation, and a corresponding anion. Hold on. I forgot to take off I don't like how it does the dissolving thing, and I take them off the slides, and I forgot to do it, so this one's going to have the slides on it, showing it like that, unfortunately. So electrolyte solutions are ionic compounds that dissociate in water, and electrolyte solutions contain dissolved ions. So we can show the process of dissociation or ionization using either molecular or ionic equations. Molecular equations show all ions together as compounds, while ionic equations show dissociated ions as separate species. For example, solid potassium bromide and gaseous hydrogen bromide both produce ions when dissolved in water. We can write these molecular or as ionic equations. For potassium bromide, I just want to make sure I have them on here. We can write a molecular equation like this. So you see it has a solid, and it goes from solid to aqueous because it has now been dissolved in the aqueous solution. Or you can write it as ionic, where you see the solid and then it goes into the ions separately where it dissolves, and it shows the dissociated ions as separate species. You can do the same thing for hydrogen bromide. You can write a molecular equation, which means intact, where the compounds are shown together, and the only difference is the phase. Or we can write an ionic equation, which shows the ions separately. I'm just going to get through all of this because I don't like I remove all of that, and I forgot to. Suppose 1 mole of magnesium chloride is dissolved in enough water to make 1 liter of solution. The concentration of magnesium chloride is 1 molar, or 1 mole per liter. However, magnesium chloride is an ionic compound, so it dissociates when dissolved in water, as shown in this ionic equation. Notice that when the solid dissociates, 2 moles of chloride ions form for every 1 mole of magnesium ions. This means that the concentration of the chloride ions in the solution is twice as high as that of magnesium ions. We could describe this solution as having a 1 molar concentration of magnesium chloride, or we can describe it as having a 1 molar concentration of magnesium ions and a 2 molar concentration of chloride ions, and both descriptions are correct. As an analogy, think about a grilled cheese sandwich. The sandwich is made of 1 slice of cheese and 2 slices of bread. If everyone at the table has a sandwich, you can also say that everyone has 1 slice of cheese and 2 slices of bread. So what is the concentration of sodium ions and sulfate ions in a 3.5 molar solution of sulfate? So, yep, here I left it all. Make sure it's all out. Okay, so what is the concentration of sodium ions and sulfate ions in a 3.5 molar solution of lithium sulfate? We must recognize that the ionic compound dissociates into solution. So the first thing I would tell you is to do a balanced equation. It's the easiest way to understand what's happening, unless you can visually determine that there's two moles of this and 1 mole of that, and then you can do the math that goes with it. If not, I would, in the beginning, you're going to need to know how to follow this through chemistry anyway, so it just straightens those skills. Notice that we get 2 moles of lithium ions for each mole of lithium sulfate. As a result, the concentration of lithium ions is 2 times 3.5 molar, or 7 molar. Since there's only 1 mole of sulfate in each mole of lithium sulfate, the concentration of sulfate ions is 3.5 molar. So you take the concentration and you basically multiply it by how many there is. So in this case, that's where the 3 times 2 comes in, and here it's 1, so it's 1 times 3.5. Okay, so I'm just going to bring everything out. I don't like it like this. No. Okay, so now let's look at this one. Write an ionic equation showing the ions formed when ammonium phosphate dissolves in water. What is the concentration of ammonium and phosphate ions in a 0.928 molar ammonium phosphate solution? So again, pull out and make, it's asking you specifically now, do an ionic equation. So you should be able to pull out the ionic equation. And then what I do is I write out underneath everything that I need for it. So in this case, I would write down here 0.928 molar, and then I would write I would write this here, and then I would write this here. So I can see everything directly underneath where it needs to go. But in this case, they're just separating. Now, these brackets here mean concentration. So that's what it's asking for. So molarity. So in here is a 0.928 molarity for the whole entire compound. For the ammonium, there's 3 moles, so that's multiplied by 3 gives 2.78, and then there's 1, so it's 0.928 molar. Okay, so let's take a look at the, again, review here. Ionic compounds dissociate in water. Electrolyte solutions contains dissolved ions. So if we look here again, review, magnesium chloride, let's say it's 1 molar, that means 1 mole per liter, but in there is 1 mole per liter of magnesium ions, but there's 2 moles of chloride ions per liter. So let's break this down here. I'm just going to show the actual page so we can go through this. All right, so if we have a solution of 3 molar sodium chloride, it's best to write out an ionic equation so you can see everything. So if you have that, that means that there's a total ion concentration of 6 molar. Where did that come from? Well, it's 1 times 3 for sodium ion and 1 times 3 for chloride. And that makes 3 plus 3 is a total ion concentration of 6. Here we have sodium sulfate. So this would be 2 times 2, that's 4. And this 2 times 1 is 2, so 4 plus 2 is 6. Here we have a 5 molar concentration. 2 times 5 is 10. 1 times 5 is 5. 10 plus 5 is 15 for a total ion concentration. 4 molar is 4 for the whole compound. 3 times 4 is 12. 1 times 4 is 4, so 12 plus 4 is 16. Hopefully I didn't go too fast and that makes sense. But do you see why you need to write out the ionic equation? So you can see exactly how many you have, unless you can visually separate this out by just looking at it, which isn't always the case. How many moles of sodium ions are there in 1 liter of a 0.5 molar sodium phosphate solution? So in this case, write out the balanced equation. Write it out because you might not always get the answer right if you don't. And so in this case, I wrote it out so you can see. I wrote this underneath this one. 3 times 5 is, I forgot what it is now. I should have wrote out the actual answer. Is 1.5. And because here's the answer here. But I checked on the calculator just to make sure my math is right. So it's 1.5. Notice this is asking about sodium ions, not the total ion concentration, but the sodium ions. So the answer would be this, which is C. Which of these has the highest concentration of ions? So in this case, you just have to break it out like I did here and then check the answers. So I kind of helped you out here by pulling it all out. And B is going to be the answer because you can see here it's asking for sodium. So we only care about sodium. We don't care about the anion. So this one's going to have the highest concentration. This is 0.2 molar times 2 equals 0.40. And you see this one down here is 0.3, 0.3, 0.2, 0.1. So this one's going to have the highest concentration.